This video covers section 4.4 from your text. In it we will be learning how to solve applications involving systems of equations. And just like we have in the previous sections where we learned the substitution method and the elimination method, we will be using those methods to help us solve these applications. The only difference is before they would give us a set of equations like 2x plus 3y equals 7 and 4x minus 5y equals 12, but we would have to solve the given equations. Well, here we're going to solve those equations the same way. We just have to come up with the equations. And to come up with those equations, there's really two things you want to look for most of the time, and I have them written out here. You can add them to your notes. And the first thing is totals. So it might say something like total cost or total weight or total perimeter or something like that. It's going to be some total, and in this case it's usually like something plus something adds up to be some total. And then the last type you're going to see where we could come up with equations is 2 here, where it says sentences that describe one unknown in terms of another. And what I mean by that is, in the second example, something like that, where it says the length, which is an unknown, is 5 inches more than 3 times the width. Because we know that's an equation. We've learned how to write these before. The length, that's going to be L, remember is what? It's equals, is 5 more than 3 times the width. So 3 times the width is 3W, and then it's 5 more than that, so we add 5. And that's an equation. Remember, we need 1, 2 equations. So we got to be able to come up with those 2 equations in each one of these problems. So let's go ahead and read through the first example. It says adults are charged $8 and children are charged $4 to attend a fundraiser dinner. If 112 people attended the dinner and $788 was raised, how many adults attended the dinner? One of the things I'd like you to get in the habit of doing right off the bat is to define your variables. Remember, there's always 2 variables. We're used to seeing x and y, but in this case it's going to be something else. And here we're talking about adults and children, so I think we should use A and C for our variables. Now if you're more comfortable using x and y, that's fine. But if we used A and C, A would be the number of adults, and then C would be the number of children. And so our 2 equations will involve those 2 variables. Now, what kind of information is given? Let's look for totals first. If you notice that the very first total is this 112 people. There's 112 total people. And then also there's another total. It's the amount of money raised. There was $788 raised. And so we should have 2 equations with totals. The first one being that it's going to add up to 112 people. And then secondly, a total of $788 raised. And so the first equation, 112 people, we don't know how many of those were adults and how many were children, but we know that the adults plus the children should be 112. So that's kind of the most basic equation you'll see there, just A plus C equals 112. Now the second equation, that gets a little bit more complicated, but not a lot. When we have the amount of money raised now, it's that each of those adults, remember A is the number of unknown adults, pays $8. So if we take 8 times the number of adults and we add to that $4 per child times C, the number of children, that total should add up to $788. And now is the place where we can either use substitution or elimination to solve this, and it's your choice, whatever method you feel more comfortable with. This is actually, you remember, if anywhere in the equations we have variables, or in front of the variables we have numbers, a lot of times those are not good candidates for substitution. But like the first equation, we could solve for say A or C and do substitution, or we could just start with doing the elimination method, because I could multiply this top equation by -4. And if I multiplied the top equation by negative 4, I would get negative 4a minus 4c, and then 4 times 112, what's that going to be? That's going to be negative 448. In the bottom equation, we don't need to change. We can just leave it as is. So 8a plus 4c equals 788. And then we go ahead and add the equation. So negative 4a and 8a, that makes positive 4a. The c's cancel, and that's equal to 340. And we go ahead and divide that by 4. We get 85. So a is equal to 85. Now we know we can substitute this back into either equation. I would probably substitute it back into the first equation because it's simpler. So we do that, and we plug that in for a. This becomes what? It becomes 85 plus c equals 112. Move that 85 over to the other side. Subtract it from 112, and we get our number of children. Our number of children is equal to what? 27. And then, just like with any application, we should go ahead and write this in a complete sentence. So 27 children and 85 adults attended the fundraiser. Okay, so that's the idea with these. I'm not, for each of the rest of the applications, I'm not going to go all the way through and solve. I just want to kind of go over how to set them up, because we already know how to solve these. So moving on to the next one, it says the length of a rectangle is 5 inches more than 3 times the width. We already wrote that equation. Let's see what else we have, though. It says the perimeter of the rectangle is 114 inches. Well, we know with the rectangles that perimeter is equal to 2w plus 2l, and in this case it told us the total perimeter was 114. So we have our two equations. Which method is going to be best here? Well, how about we just substitute? We take what L is equal to and we plug it in for L, because then when we go to rewrite the second equation, we get 114 equals 2W plus 2 times 3W plus 5. And you could finish it from there. Okay. Actually, let's go ahead and finish this one. So this one is 2W plus 6W plus 10. If we go ahead and distribute there, equals 114. This is 8W plus 10 equals 114. This is 8W. If we subtract 10 over the other side, is 104. And if you divide 104 by 8, you get 13. You get W equals 13, and the length is just 3 times that 13. We're plugging back in for W up there. L equals, I'm using the first equation, L equals 3 times width plus 5. 3 times 13 is 39. You add 5 to that, you get 44. Now we should have units here, so this is 44 inches and the width is 13 inches. So that's that one. Okay, now the last 4 examples, though, we will not work out and solve. I wanted to do those first 2 to give you an example reminder of working with elimination and substitution. The third example says a jar contains nickels and dimes. If there are 34 coins, oh, there's a total, so 34 coins in the jar. This is coins, total coins. And their total value is 305, so that's another total, so we can put equals 305. This is total value. What do we know? We know we want to find how many nickels are in the jar. So let's let x, or how about n? N be the number of nickels, and let d be the number of dimes. And we know the total number of coins, that's nickels plus dimes, is 34, so we can just say n plus d equals 34. That's total number of coins. And in value, we have to take the number of nickels and multiply it by how much. How much is a nickel worth? Well, that's 5 cents. And then we add that to how much a dime's worth times the number of dimes. So that's 10 cents per dime times the number of dimes will give you a total value of 305. And those are two equations. And you just want to go ahead and solve that. We're not going to do that in this video because that's something we practice enough now. Okay, I'm going to go ahead and move on to the fourth example. This is investing, talking about interest. Remember, if we're talking about annual interest, annual simple interest, that is that I is equal to the principal times the rate, or the amount invested. That's the principal. Amount invested times the rate. So it says Jessica invested a total of $7,000 in two funds. There is a total. So she invested $7,000 in the first year. The first fund increased by 6%, and the other fund increased by 14% in the same period. If Jessica made a total profit of $620 from these two funds, oh, there's another profit. And when it's talking about profit, that is interest. That's how you make money with investments. You earn interest. So she made $620 from these two funds. How much did she invest in the fund that made 14%? So we don't really know how much was invested in each fund. So let's say X is the amount in the 6% fund. And let's say Y is the amount in the 14% fund. We know we have two totals. We have total investment, and then we have the total interest. This is investment, and this is interest. So the first equation should be easy. We have a total of $7,000. We know we have X in the 6% fund, and we have Y in the 14% fund. So you add those two together, you get a total of 7,000. Now, each of those amounts, the X and the Y, both earn interest at different rates. So we have to take the amount P, which is going to be our X's and Y's, and we have to multiply those by the rates. So the 6% amount, remember you have to write this as a decimal, so 6% equals 0.06. That 6% amount was 6% earned on the amount X, and then we have to add to that the amount, which is 14% times amount Y. So that's percent times amount plus percent times amount equals a total interest of $620. There's equation 1 and equation 2. Okay, and then of course, as a reminder, you could go ahead and solve both of those equations using either method. Okay, Michael drove his car to the foothills at a speed of 70 miles per hour. Once he got to the foothills, he took out his bike and rode it at a rate of 30 miles per hour. If his total trip took 4 hours and covered a distance of 140 miles, how long was Michael riding his bike? So there's really two unknown times there. We don't know how long he drove, or rode the bike. So let's say X is the time in the car and Y is the time on the bike. And the key formula here is going to be our dirt formula. Remember that one? Distance equals rate times time. Because we have, for example, we know a couple of totals. We have a total trip of 4 hours in time and a total distance of 140 miles. So we have 4 hours total time and 140 total miles. First equation should be the easiest one because we already defined variables x and y to be the time in the car and on the bike. So if we split that up, x in the car plus y on the bike should equal a total of 4 hours. Now the distance, the 140 total miles distance, that has to come from this rate times time. So if we take the car where he was driving at 70 miles per hour, that would be the rate or the time? Well, that's the rate. So, because remember, distance is rate times time. So if we take 70 miles per hour times the time in the car was x hours, and we add to that the time on the bike, and the bike they were driving at 30 miles per hour, so that's 30 miles per hour times y hours. That should equal a total of 140 miles. That's equation 1. And equation 2, again, you can solve this in whatever method you choose. We have one more example here. So the last problem is a mixture problem. It says a chemist has one solution that is 60% acid and a second solution that is 50% acid. She wants to combine the solutions to make a new solution that is 54% acid. If she needs to make 400 milliliters of this new solution, how many milliliters of the two solutions should she mix? So we have two unknowns here. We have x and y. X is the number of milliliters of the 60% solution. And then, of course, y is the other one. Y is the number of milliliters of the 50% solution. And kind of, I always like to draw a diagram for these. So if you have a solution that's in a cup, this one's the 60% stuff, and then we have some, it's a little bit more diluted, we have the 50% stuff, and we want to mix those together, add a little bit of this and a little bit of that to get a mixture. And the mixture is 54% acid, so it's 54% mixture. And we don't know how much of each of those types. That's what we're trying to figure out, the x and the y. So there's x milliliters of that and there's y milliliters of that need to combine to make 400 milliliters of the mixture. So that really is the first equation. We just take so much of the one plus so much of the other. X plus y has to equal 400. And then we also have the acid equation. The first solution, the x milliliters, is 60% acid. We add to that the y milliliters that are 50% acid, and we get a mixture which is 400 milliliters, but 54% acid. And we could simplify that second equation a little bit, do the math. 0.54 times 400 is 216. So this is 216 there. 0.60x plus 0.50y. So that equation will become that. We don't need that one anymore. I mean, we used it to get the second one. So we use first equation, second equation, use elimination or substitution, and away you go. That does it with the 4.4 video. I will see you in class. Thank you.